Welcome all. Back here for a little algebra. So today we're talking about equations of lines and modeling, specifically just the equations of lines. So up to this point, we have dealt mostly with the slope-intercept form. That's been our main focus throughout. Today we're introducing point-slope form. Now, slope-intercept form is called that because one, you have the slope right there and the y-intercept right within your graph. Same thing over here. So point-slope, then using the same keynotes here, we got your slope and you got a point x1, y1 right there. So here's our equation. We're going to do both. We're going to use both equations to solve this. This is find the equation of a line containing 0.23 and 1, -4. Okay. So first things first, we need to find our slope. We have to have our slope on either one of these. So our slope formula is y2 minus y1 over x2 minus x1. Now, here's the first set. So this will be our x1, y1, 1, 1, y. This will be our x2, y2. Okay, so let's plug those in. We end up getting -4 minus 3 all over 1 minus 2. We end up getting a -7 over -1, which gives us a slope of +7. So we'll start with the slope-intercept formula. So as we set this up, we got y equals 7x plus b. Now we don't have a y-intercept right now, but what we do have is our slope. We have to have this. So to do so is we're going to take this first set of numbers, and you can use either one, but I prefer the 2 and the 3 because they're both positive. And we plug them in for the x and y here. So we end up having 3 equals 7 times 2 plus b. We do the math here. We end up getting 3 equals 14 plus b. Solve for b by subtracting 14 from both sides. You end up getting b to be -11. Now we then take this value right here and we substitute it back in for the b up here. So our final equation will be in the form of y equals 7x minus 11. So that's our equation in slope-intercept form of this problem. Now the next one is do the same thing. We still use the same slope, so the slope doesn't change. So we got y minus y1 equals our 7, the slope we found, parentheses x minus x1. Now to finish out point slope, we need to substitute values in for that. Well, let's go ahead and use the same x and y as we did earlier. So we end up having y minus a 3 equals 7 parentheses x minus 2. Now, as far as writing the equation, you're done. You wrote it in point slope form. You're good. Well, let's double check it. Let's turn this into slope-intercept form. So we'll distribute the value of 7 through. So we got y minus 3 equals 7x minus 14. All right. Then we'll add 3 to both sides. We end up getting the equation y equals 7x minus 11. Look at that. They happen to be the same. So yeah, regardless of which form you do, you can use it. Now this one, the great thing about point slope is sometimes they don't give you the y-intercept, but they give you 2 points. Well, and then just plug that in. There's your equation. But if they specifically ask for that, you can easily turn a point slope equation into a slope-intercept equation. Okay, so now we're going to talk about horizontal lines and vertical lines, and as far as our equation of those. So we know what horizontal and vertical lines look like. Let me fix this. It's not horizontal. Move that down. There we go. That's a little more horizontal. So we have horizontal and vertical lines. We know what they look like, but do we know their equations? Let's start with the horizontal line. We have the value of y equals b. So most equations come in the form of y equals mx plus b. Well, as we talked before, when you have a horizontal line, you have a slope of 0. So you have 0 slope. Sometimes they call it, it's a 0 slope, really. 0 slope has a value of 0. So if you put a value of 0 in for m, 0 times whatever x is still gives you 0. So that's how you end up getting y equals b. B is also the y-intercept anywhere on here. So for example, this first one runs along the x-axis. That means, there's school bell. That means that the value of y is 0. Y equals 0. But let's look at this. How about this one down here? This has a value of 1, 2, 3, 4, 5, 6. Negative 6. So that means the equation for this is y equals negative 6. So that makes sense. Horizontal line. But let's go vertical lines. Vertical lines, kind of weird. We have an x, no y at all. Let's say x equals a, where a is an actual number, and it happens to go through the x-axis. That's how we get those vertical lines. Now here, because x equals a number, we have no slope, because it climbs infinitely up or goes infinitely down. No slope, also known as undefined. These equations are similar to the x one. So if your line, wherever your line goes through, that x value on the x-axis, that is the equation. So for example, this one right here is here's the ordinate, go 1, 2, 3. The value of x is 3, so the equation is x equals 3. This next one right here, it's at negative 7, so x equals negative 7. Now, let's talk about parallel perpendicular lines and what makes them special. Now, parallel lines are special because they have the same slope. Their slopes are equal. So if you ever see parallel lines, automatically think same slope. Let's kind of test that theory out. So here's two lines that are supposedly parallel. Well, let's figure it out. Let's look at the slope of this one. Here's a point of intersection. Here's another point. This other one right here. Here's a point of intersection right here, and here's another one right there. Let's change the color so then we know we're talking about different ones. This slope and this to here. So this first one, to figure out the slope using the graph, we just count. We go up 1, 2, 3. So rise 3, and then 1, 2, 3, run 3. So it's 3 over 3. Okay. And then the next one, just check the one below it. You rise 1, 2. Oh, we only went 2. And then you run 1, 2, 2 over 2. Well, if we reduce them, we get 1 over 1, 1 to 1. So that means they're equal. So that means they are parallel. Now let's look at perpendicular slopes. Now perpendicular slopes are perpendicular if the product of the slopes is negative 1. So as we were saying earlier, the letter m represents slope. So if I take the m of one times the m of the other one, somehow I'm going to get a negative 1. Let's test that out. So for example, let's start with this one right here. So here's a point of intersection, and here's another one right here. So let's count the slope of that one. So it goes up 1, 2, 3, 4. So it goes up 4. And then over 1. All right. Let's check this other one over here. So using the same point right there, and then we'll use this point over here. So it goes down 1. So that's a negative 1. And then over 1, 2, 3, 4. Over 4. Now if I multiply these two, I get 4 times negative 1. I get negative 4. 1 times 4 is 4. Negative 4 over 4 gives us a negative 1. So yes, they are perpendicular. Now, what's also great about this is the way you can think of them as far as when we say parallel lines equal same slope. With perpendicular lines, so perp, I'm going to abbreviate lines, equal, they're negative reciprocals of each other. Reciprocal. They're negative reciprocals of each other. That means if my slope is 2 over 3, and I want to do the perpendicular to that, I do a negative, so it'd be negative 2 over 3, and then the reciprocal of that, which then gives me negative 3 over 2. So this slope and this slopes are perpendicular to each other. They're negative reciprocals of each other. So let's kind of take a problem here and test it out. So it says write an equation in slope-intercept form of a line that passes through the given point. Here's our given point, and is parallel to it. But we're also going to write a second problem that runs to that same given point, but is perpendicular. So we're looking for a parallel equation and a perpendicular equation. So we're going to start with the parallel one to make it easier on us. So when things are parallel, remember we say parallel lines means same slope. So we're going to take the slope of the given line as it is and make our new line. So y equals 2 over 7x plus b. Now we say plus b because the b's are changed. The y-intercept is different. So to figure out our new y-intercept, we do what we did at the very beginning. We substitute the value of this x and y into x and y right here, the given line. So we'll have 5 equals 2 over 7 times 3 plus b. We multiply this out, we get 5 equals 6 over 7 plus b. Again, since this 6 over 7 plus b is a positive 6, to get rid of it, we subtract 6 over 7 minus 6 over 7. So when doing so, you're taking a whole number 5 over 1 to be exact, minus 6 over 7. Common denominator is 7, so we multiply the top and the bottom by 7s here. We end up getting, I'm going to put a little line here so it doesn't run into it, 35 over 7 minus 6 over 7. We simplify that, we end up getting 29 over 7. That equals our b. So we substitute this value back in here, and our equation will be in the form of y equals 2 over 7x plus 29 over 7. It's okay to have fractions, multiple fractions over here. Nothing wrong with that. As long as we have isolated y, then our equation is set. But that's part one. The next one's saying, hey, I want you to do perpendicular. Now remember, when we think about perpendicular, we're thinking about negative reciprocals. Negative reciprocals. So we take the slope of what it is right now. It's 2 over 7. So our slope is 2 over 7. And we're going to do a perpendicular to that. So when we do perpendicular, we do negative. So it'll be negative 2 over 7. And the reciprocal of that, giving us a negative 7 over 2. Negative 7 over 2. So that's our new slope. So our equation right now looks like this. Y equals negative 7 over 2x plus b. So we run into the same problem as before. We have a b, our y-intercepts are different, and they should be, but more specifically, we don't have a value for a y-intercept. So to figure that out, we take that same 3 and 5, and we substitute it into here. So 3 in for x, 5 in for y, so we got 5 equals negative 7 over 2 times 3 plus b. We multiply this out, we get 5 equals negative 21 over 2 plus b, and again, to get b by itself, we'll then add 21 over 2 to both sides, plus 21 over 2. So we look at it side by side, we got 5 plus 21 over 2, more specifically, 5 over 1. So common denominator is 2, so we multiply the top and the bottom by 2. We'll have 10 over 2 plus 21 over 2. When we add them up, we get 31 over 2. This is the value of our b here. We then take that and plug it back into our equation. We get the equation y equals negative 7 over 2x plus 31 over 2. This is our perpendicular equation. So as you go through the homework and you work this out, remember, perpendicular lines are negative reciprocals to each other. Parallel are the same. Now, there's other questions throughout here will ask you, is this parallel, perpendicular, or neither? The only time it's neither is when it doesn't fit any one of these two criteria. Again, as we said earlier, parallel lines should match up as far as the slope. So we always got to figure out what's the slope of this line, what's the slope of this one. When we took them and reduced them, they both were the same. 1 and 1 on this one right here. So that's how we knew they were parallel. On this one, when we reduce them, or when we put them in, they were negative reciprocals from the very beginning. They look very similar, but they just switch up and down, and one's positive, one's negative. That's negative reciprocals. It's perpendicular. But what if we compare this and this slope? These two slopes have no relation to each other besides that there's a 1. Well, this is 1 over 1. They're neither opposite sign. They're neither reciprocals to each other. So this is what we call neither. They're neither right here. Okay? Good luck, y'all. Have a wonderful day.